Hello students, today we have second assignment of chapter 8 electromagnetic waves. Though there are 8 questions in this assignment, all are related to properties of electromagnetic waves. There are 9 properties of electromagnetic waves, and if you understand all the 9, you should be able to solve all these questions. So I am not reading out individual questions. Let us directly go to 9 properties of electromagnetic waves. As now we know that electromagnetic waves are actually any wave is disturbance of electric field and magnetic field. So when you are talking about electromagnetic waves are disturbance of electric field and magnetic field. So if I represent variation in electric field and magnetic field with this, see what is happening. Electric field vectors are oscillating in this manner. So how do I describe this? So we say that if this is the direction of propagation, then electric field vectors are perpendicular to the direction of wave propagation. So how do we label this? Let us consider this direction as say x direction, and then this will be y and this will be z direction. So if I consider electric field vectors to be oscillating along x direction, magnetic field will be oscillating like this. See, what I am doing is I am making sure that where electric field is 0, exactly at that point magnetic field is arriving at its peak. Where it is happening in inductive component, right? So this is the variation of magnetic field. Now, how many things we are supposed to know about electromagnetic waves? So very firstly, electric field and magnetic field both are varying and both are function of sinusoidal wave. So you can say that if you can represent electric field in terms of wave equation, it would be E0 sine omega t minus kx, and it is along y direction in this particular case. B is B0 sine omega t minus kx along k cap. So this is very first property of electromagnetic wave, that this is how you can represent the components of electric field and magnetic field. Mainly three quantities you have to be careful about. When you say Et and Bt, these are instantaneous values of electric field and magnetic field. You may be talking about E0 and B0, that is maximum value, instantaneous values, maximum values of electric field and magnetic field. And when you are talking about energy or power delivered or intensity of electromagnetic wave, at that time we will consider ERMS and BRMS, RMS values of electric field and magnetic field. But electromagnetic waves are transverse wave. They have electric field and magnetic field, which can be represented by these two equations. What is omega? Omega is 2 pi f. You may also say it is 2 pi by t. What is k? K is wave vector 2 pi by lambda. So this is very first property of electromagnetic wave. Second property says that there is relation between electric field and magnetic field, which can be given as E by B is equal to C. What is C? C is speed of light, velocity of light in vacuum. And this is true for E0, B0. This is true for ERMS by BRMS. Let me give it proper numbers. Let me label this as first property, and this one is second property. Let us go to third one. The speed of light actually depends on the medium. So it is given as c is equal to 1 by under root mu 0 epsilon 0. If you check dimensionally, you will come to know that this is holding true. So if you are talking about some other medium, speed of light in other medium can be given as mu and epsilon. What is mu? Permeability of given medium, magnetic permeability of given medium, epsilon is permittivity of that medium. So then, if I take refractive index of any medium, it is C by V. So take ratio of this two. What you will have? You will get mu by epsilon upon mu 0 by epsilon 0. But mu 0, sorry, mu by mu 0 if you take, it is relative permeability, and epsilon by epsilon 0 if you take, it is relative permittivity. So I can say that eta is nothing but mu r into epsilon r, or mu r into k, dielectric constant. So what this suggests? This suggests that speed of electromagnetic wave is decided by the refractive index of any medium, and this is how you can find out. Use these three equations and you will come to know how refractive index affects speed of light. Next one is that electromagnetic waves are transverse waves. What do you mean by transverse waves? Electromagnetic waves are the waves in which the direction of oscillation of electric field and magnetic field are perpendicular to the direction of wave propagation. So that is how these waves are transverse waves. Next, electromagnetic waves carry energy. Though there are no particles, these are not mechanical waves, so there are no particles, but these waves do carry energy. So when waves travel from one place to another place, you can say that energy is flowing from one point to another point. Next, whenever electromagnetic waves fall on any surface, they are carrying energy with them, and hence the surface experiences pressure. So how do I know how much is the momentum transferred or how much is the force experienced by the surface? So we know that the energy carried, if it is say delta U, how do I find out how much is the force exerted on any surface? So that can be given as delta U by C is equal to delta P. What is delta P? Delta P is the momentum gained by any surface. The next one is important, the energy carried by electromagnetic wave. Now we know that electric field and magnetic field both are there. So how do I find out energy density uh, of this wave? So if it is rho, I can say that it is energy density due to electric field plus energy density due to magnetic field. That is half epsilon 0 E square plus half half B square by mu 0. Which E and which B we are talking about here? It is RMS value. So E RMS and B RMS. So now we know that look at the third property. Okay, look at this equation. So using this equation, I can say that rho is half epsilon 0 E RMS square plus half If I take square of this equation, what I'll have? C square is equal to 1 by mu 0 epsilon 0, and if I take epsilon 0 on other side or mu 0 on other side, I'll have 1 by C square epsilon 0. So that is what I want to use here. So what is 1 by mu 0? 1 by mu 0 is epsilon 0 C square. So I can write here epsilon 0 C square. Is that okay? And then sorry, it is B not E, B RMS square. Now we know that E RMS by B RMS is nothing but velocity of light c. So I can replace B RMS with E RMS by c, and then this equation will be half epsilon 0 E RMS square plus half epsilon 0 c square. Instead of B RMS, I'll use this equation, and then what I'll get? E RMS square by c square, and then I end up with half epsilon 0 E RMS square plus half epsilon 0 E RMS square, and that is ultimately epsilon 0 E RMS square. This is the energy density of any electromagnetic wave. Now you can similarly express it in terms of B RMS also, and then the equation will be B RMS square by mu 0. So this is the energy density of any electromagnetic wave. Now, lastly, we know that different sources produce electromagnetic waves of different intensity. How do we define intensity of an electromagnetic wave? So, intensity I is defined as energy per unit area per unit time. So, how much now I can also write this as power. Energy upon time is power, so you can also say it is power upon area. So how many units? You can express it in terms of joule per meter square second, or else you can write it as watt per meter square. These are the units of intensity. So now if I take I as delta U upon A into T, we know that energy density rho is delta U upon volume, that is area into distance. So I can write this delta U as density into area into distance L, and then uh, we end up with energy density into C. So now if I substitute rho value, I realize that it is epsilon 0 C E RMS square, or else I can write this as C B RMS square by mu 0. So here we have three equations of intensity. We can write intensity as energy density times speed of light. You can write intensity as epsilon 0 C E RMS square, or else you can express intensity in terms of BRMS. It is BRMS square times C upon mu 0. So these are the three equations of intensity of light. And lastly, we know that electric field and magnetic field both are perpendicular to the direction of wave propagation. So the direction of wave propagation can be obtained by taking E cross B. Find out E cross B, and the direction of E cross B is in the direction of wave propagation. So these are the 9 properties of electromagnetic waves, and from all these 9 you will be able to solve today's assignment. Thank you.